The command ps shows all running processes. Its variant, ps-aux, displays processes for all users. The command top shows processes as well, but it also gives you the ability to automatically track changes in their activity in real time and sort them by runtime, CPU usage, and memory usage. It is, therefore, more or less equivalent to the task manager in Windows, except that it's displayed in the text format. However, its functionality is exactly the same, allowing you to monitor which applications use how much CPU or memory. wget downloads files from the internet, just as it could be done through the web browser. This is especially useful while writing scripts. You can create a script with this command that will first download some file from the internet and then unpack it automatically. Eject can be useful when the drive does not eject. In the past, Linux used to block all attempts to remove the CD manually. The reason was to prevent situations where someone ejected the CD while it was being read or written. In Windows, it was possible, but it resulted in a so-called blue screen with a message that there was an error while reading the CD. To avoid this, in Linux systems, CD drives used to be locked, and some distributions still have this feature. The eject button was by default disabled and simply didn't work. First, you needed to unmount the drive and then execute the command eject. Currently, in most cases, you can simply press the eject button, and the disk will automatically be dismounted and ejected if no application is currently using it. In rare cases, the system won't give in. The eject command usually forces this operation. Let's see what happens when you run the commands ps and top. When you enter the command ps, the system will display current user processes. In our case, this is just bash, that is, one terminal and the ps command itself. If you type ps-aux, it will display all running processes for all users. Although Linux will display them, a regular user such as us can only manage their own processes. That you can see a process launched by the administrator does not mean that you can do something with it. From the point of view of the system, displaying it doesn't carry any risk. In Windows, you need administrator privileges to be able to see processes run by other users. This is because permission control in Windows and Linux differs. The top command displays a table in which the processes are sorted, by default by CPU usage. You can change the type of sorting by pressing inequality signs. If you press the greater than sign, you'll move one column to the right, and applications will automatically be sorted by memory usage. If you press it once again, applications will be sorted by runtime and then by name. The button less than scrolls it all back one column to the left. In general, data in the table can be sorted by any of the characteristics seen in the column names. You can change it using shortcuts Shift plus dot and Shift plus comma. Moreover, top displays some additional information about the system. You can also see the number of running processes. A more interesting piece of information is CPU usage. In our case, it's relatively low. You can also read statistics on total available memory, used memory, and free memory. There are also statistics on swap space. You can view total, available, and used swap space. Linux doesn't use shared memory very extensively. Therefore, there is no point in setting its value above a certain limit, which is by default 2 GB. There's no use in making swap files bigger than that. You terminate this command by pressing Q. It will take you back to the console.